Hello students. So today we are going to discuss about the segmentation process, and we will learn that what is the segmentation process, because paging and segmentation both are important in your virtual memory. So before we are going to the virtual memory, we will first learn about the segmentation process. Okay. So I will suggest you, because there are many examples on the base of the paging, segmentation, and mapping, cache mapping. So there are many examples on these things. So I will suggest you that you should do some of the examples by your hand, so that it will be more clear and will be beneficial for you in the examination. So let's see what is segmentation. So segmentation, in this case, the process is divided into size of process and put in the main memory. So for example, if there is any process and it has some size, then it is divided into the main memory. It is divided into some sizes and put it into the main memory. So each and everything which is storable is in the main memory basically. So we have so there are one of the case, this is a program. This is, for example, this is our any of the program, and it has some of the program modules, for example main, and in this main there are some modules. S1 is another module of the main, which is addition, subtraction, multiplication. So whenever there is addition, so there is a size of this process. So addition is one of the process, and the size of the process is defined in it. And S2 is another process. So S2 is another process, and the size of this process is defined in it. Okay, so these all things are the processes, and we divided these all things in the segments. So S1 shows the segment 1, which shows the addition. S2 is the segment 2, which shows another process, and so on. Okay, so whenever this is our logical address space. This is our logical address space. This whole one is our logical address space, and in that case we have segment number and the size of the process. Okay, so whenever the processor generate any address, it will provide the segment number, and it will provide the size of the process, that what is the size of the process is there. So now there is another memory management unit, and in this memory management unit we have segment number, and this segment number has a base number and size number. So base is your this one, and 3300 and 1800 and 2700. This table is also defined in the main memory. So we no need to worry about the things that how will we get this table, this segment table. This segment table is also provided in the main memory. Okay, so the things are defined in the main memory by means of the base address and the size. So there is a particular segment number, that is segment 0, segment 1, 2, and so on. So likewise the segment table is defined in the main memory. Now we need to define that what should be the size of the D. Okay, so if defined D, for example, because what will the processor do? It will provide the segment number and the size of the process. If my D is less than or equal to the size of this one, okay, the size of process, then it's okay. It will go to the main memory and do whatever it needed the data. Fine. But if it is also possible that D is not defined in the in the given values. For example, it may be 202, it may be 205, 210, and anyone else. Okay, so what will we do in that case? In that case, what we will do, we will generate a trap signal. Trap, you know that trap is a interrupt signal, and in that case the control is transferred to the processor only. The control is not given to the user, it is transferred to the processor. Okay, so computer then take some time to fetch the data from the hard disk drive to the main memory, and then it provide to the processor. So in that case we have segment size offset, and this segment size offset which we have a segment number from this table, and we will find that what is the value of the D, if the value of the d is less than or equal to the given size which are given in the given here. If this is equal or less than, then it's okay. It will just add the number and it will provide the destination. Okay, but it will provide us the destination. But if it is not happening, then trap signal will be activated, and then trap signal will provide the control to the processor. Then processor take the data from the hard disk drive to the main memory, and then this can be assessed by the processor. So that is a basic idea of the segmentation process. So in that case, you can see that we have segment number and segment size of offset, which is S and D, and physical address depends on the base address plus size of the process. Okay, so in the physical address we have base address, basically that is my base address. For example, so if it is a 0, so 3300 plus the size of the process is 200. So it is defined here, and it will provide us 3300 plus 200. It will provide us 3500. So here we can discuss that a physical address depends on base address plus size of the process. Another things are segments are of a various size. CPU will generate logical address. Logical address, we know logical address, that this is our logical address. This space is of our logical address. It will define the segment number and the size of the process. That's it. Okay. Another thing is your logical address must be converted into the physical address using MMU. So memory management, MMU is memory management unit. Fine. So MMU is this one. This is my memory management unit, and it will provide that what segment has what base address and what is the size. Okay. So this is all about the segmentation. And next here you can see that there is a segment number and segment size. So it may show you the segment number. It is 001, and it is showing the 10000 is my segment size. So in binary, what is the whatever that is the number. So 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, 2 raised power 4. Okay. So it is a fifth number, so it is 32. So next is 001. So segment number 1. So it is showing that it is a segment number 1, and this is my size of segment. So then it is my logical address. So here you can see that it will have this one. Okay. Accordingly, so I will go to this segment number. This is my segment number. According to the physical address of the CPU, this is my segment number. And in that case, what is the size of the process? It is 32, and it will be defined by this size. So my size must be in that range. So it should not be more than 400. Okay. So likewise, this we can generate our logical address. So in my next lecture, I will tell you that what is virtual memory and how it works. Thank you for this lecture.